1, 2.
Okay, good morning. So welcome to the DIME working group session. I think that we will wait for a few minutes. I think that one ID should show up somehow. So we will have the blue sheet to circulate. We will need a 1 minute clicker because the traditional one is not available today. So who would be volunteer for that? Someone? We just need some formal minutes. I think that's... so Jean-Jacques. Thank you, Jean-Jacques, for volunteering. And thank you, Martin. And someone would be in the Jabber room. I don't know if maybe Stéphane will be on the Jabber room. So I would like to have someone on the Jabber. Sorry? Okay. So you will monitor if there is something on the Jabber? Okay, thank you. And okay, so welcome. I am Lionel Morand, working group co-chair with Uni, who's there. And so the note well I will not go through. You should be aware of that. And the agenda for today. So we have, so the agenda batching is right now. We will provide some news about the status of the working group documents. And we will have a specific presentation for agent overload rate control. And presentation regarding 2 individual drafts for the time being, but they are candidates to be working group documents. So we will go through the load information consideration and the routing message priority. And hopefully at the end of the meeting, the ADs will show up and we will discuss charter, milestones, and so on. So about the working group status, one was published. It was the diameter application design guidelines. At the last meeting, it was at the very late stage of the publication, so it was published. And regarding working group items, we have the group signaling documents. So now it is expired, but we have received a lot of comment on these documents at the last meeting, and it was not enough time to provide a consolidated draft for this meeting. And Marco and I will try to do the job to have something stable enough to be sent for working group last call. So a new version is expected in the coming few weeks. The other one was congestion and filter attributes. So working group last call was completed. We have not received any concern about this one, so it was agreed to go forward with the draft. So it had been submitted to IESG this week, and so next step will be IETF last call and IESG evaluation. About the overload indication convenience, we had 2 working group last calls. saying that after the first one, we received a lot of comments and they were taking into account in several versions. A second working group last call was completed, no comments were received, so it was agreed to go forward. And in advance, we have requested some early IANA assignment codes and code assignment, sorry, and these codes were allocated by IANA, and now we're waiting for the proto write-up, and the next step will be a ESG submission. So we are still relying on Alan for the proto write-up. He said that it should be soon, so we are relying on him, saying that there is still a need to have a formal RFC published. So especially because 3GPPs are using this document as a reference for standard specifications. Next one is the end-to-end security requirements document. So finally, we received the new version of the document. Thank you, Yuni. That was published end of January. Martin, please.
Okay, so I mean, the end-to-end security is interesting. I know in hallway conversations within 3GPP SA3, the security group, there's discussion, but there's no official discussion of its usage. Do you or anybody else in this room know of, any group organization that were thinking of actually, supporting deploying this? Because I mean, particularly for, the one scenario I can think of when roaming between carriers, it would be very useful, but I mean.
No, I'm not aware of anyone specifically requesting this. So this actually originated years back when we were discussing pre-SA3 stuff way back, looking into roaming scenarios. But then it realized how it's realized today, and so no immediate request for this one, other than the why not? Other than that the why not fixing the end-to-end security, like now, as we don't have end-to-end security at all, so yeah.
Lionel, so we have received some informal requests from a GSMA delegate, for instance. They are working on end-to-end security to avoid some kind of SMS fraud and so on. It's basically, so GSMA is responsible for the internet work between roaming partners. So in this case, they need at least to have some integrity check and maybe some also confidentiality mechanism. And actually, one of the problem would raise with A6 with the introduction of overload control, where we would need to protect this. So for the time being, it is only an internal matter in the network, but as soon as there will be a need to have this information also over roaming interfaces, this mechanism will be needed. So no official request for today on GSMA. There is also ongoing SS3 discussion on that, but not at the official level. But I'm confident in the fact that we will receive specific requests for that. So I was saying that this document has been, so Steve?
Steve Donovan, related to this document, different topic, I just point out that I posted to the list a couple of comments yesterday about the document. I hadn't realized that it was about ready to go to working group last call, so I reviewed it. I don't know if you want to talk about those now or just leave it on the list. Either way, I mean, the comment was that a suggestion to add a couple of requirements. One, that the solution must support not encrypting routing headers or routing AVPs, and another that there be some way of identifying other AVPs that should not be encrypted as well, like overload AVPs. So I don't know if we want to talk about it now, but I just want to make sure that was.
Yeah. Yeah. Thank you. So thank you for the review, and I've checked your requirements. I think they are acceptable. I don't know if Uni have seen them. So Steve, I've sent an email yesterday proposing new requirements. So we will under that. And actually, I think that the working group last call will be also the opportunity for other delegates to provide valuable comments and to see how to enhance the document to have something strong enough to be able, based on this document, to define a security mechanism for end-to-end, so end-to-end security for diameter. It is proposed to start. So I don't know, Yudi. For you, would it be possible to? So it was decided at the last meeting that after the submission of the new version, a working group last call would be launched. So would it be okay for you to? Is it okay for you to? Do you agree that we can send this working group last call?
Yeah.
Okay. So we will do that after this meeting. Yeah, okay. Thank you. Next one is, so we have two new working group documents. So these documents were adopted after the last IETF meeting. So we have the agent overload and the overload rate control. So for both documents, revision were provided. I think it was mainly kind of clarification regarding what was done for the overload control documents, but we need review for this document, for both documents. So please comment this new working group items, and that's all. After that, we have to be included in the charter or working group documents. We have the architectural considerations for diameter load information. So this one was presented at the last meeting. It was by Ben. Today we will have a specific presentation presented by Steve. A new version was submitted, and we had also telechat and conference call with authors and people involved in these documents. So I think that Steve will present the status of this document and what should be done to have a stable document and go for working group last call. Working group document, and after that a working group last call. Last one was the one on provisioning CPE supporting IPv4 over IPv6 transitional solutions. It was agreed after the last meeting to have this document as working group document. So a call for adoption was launched beginning of January, and we have not received any comment on this one. So this document is adopted as working group document, and the version 00 has been submitted this week. So from the author point of view, this document is ready. So the next step will be a working group last call. Actually, this document has received several comments during the transitional period between informational and working group documents. So we have a version 5, and the version 5, I think, is stable enough to be pushed forward. And for this meeting, we have a new document, the routing message priorities that will be presented by Steve. So we need to review this one, to comment, and to see if this document could become a working group document. So next would be discussion regarding overload. So we have two presentations. The first one would be on agent overload documents, and after that we will have the overload rate control. So Steve, you have the floor. So I have a special request for you to stay in the box.
It's a magic box, right? So it protects me from all evil.
First one is what is the first one?
Agent overload.
This one. Please, Steve.
Okay, so we've talked about this for a little while now. This is an item that was delayed from the initial draft for various reasons. DOIC currently does not support the ability for an agent to independently advertise its own overload and for other nodes in the diameter network to respond to that indication.
Yeah.
Okay, let me know if it gets any better. I'm hearing myself. I don't know if everybody else.
Yeah, it's okay.
Okay, so next slide. The primary updates in this version were to make it consistent with the DOIC draft, with the final version of the DOIC draft, and a few editorial updates as well. I'm going to take advantage of today's time slot to explain a little bit about the extensions beyond DOIC needed for agent overload, and then hopefully that will spur either comments here today or comments on the list so we can get a review going. I have one open question, and then I've gone through a few ping pong diagrams to illustrate how agent overload would work as currently specified in this draft. Next slide. So the fundamental thing is a new report type is introduced. DOIC has host and realm report types. We are introducing what's being called here a peer report type that would be used by an agent to advertise its overload state. And then in order to handle the negotiation, there's a new feature bit introduced as well to indicate support for the peer report type. Next slide. We need to specify the interaction between host and realm and peer report types, since all three of them can appear in a single message. The proposal is that abatement for host and realm reports happens first, and then abatement for peer happens for the remaining messages that survive the host and realm reports. Now that is kind of a double jeopardy of the request does have to go through two overload abatement passes, but that is actually consistent with what agent overload is meant to do, because it's controlling the amount of messaging going to the next hop. So if you've got 3 or 4 hops later, you've got a server that's sending a host overload report, and you have an agent in the middle that's overloaded, you want to avoid, you need to reduce the amount of traffic going to that agent in the middle. The abatement in that case would likely be to select another agent, not to throttle, but to select another agent that has the ability to handle that traffic. Next slide. Attribution is something new in this draft that is not in DOIC, and what attribution means is indicating which diameter node inserted the particular set of AVPs. And there's 2 cases of attribution in this draft. One is attribution on the OC supported features header, to be able for a node to know that it was the previous hop, its peer that inserted that AVP header, and the same attribution for an overload report, to know that this overload report that is of a peer type actually could come from my peer rather than someplace further upstream. And the draft proposes using an AVP called OC source ID that includes a diameter identity of the node and then inserted either the supported features AVP or the OLR AVP. Next slide. And I'll illustrate these concepts in the ping pong diagrams. Okay, so this next slide talks about the fact that the abatement algorithm, the loss as currently defined, rate as we have a draft to define, and there could be other abatement algorithms down the road, can be different. At least this is what the draft proposes, that the abatement algorithm for a peer report can be different than the abatement algorithm specified for a host report. So a server could could indicate that it wants the loss algorithm to be used for a host report, and the agent independently could indicate that it wants the rate algorithm to be used for the rate report. And because of this, we need to extend the way that the abatement algorithm is advertised as part of the feature negotiation capability. Right now, in DOIC, if you advertise, right, most supported feature goes to the server selects what abatement algorithm it wants to be used, and it returns that in the OC supported feature header coming back in the answer message. An agent in the middle can't overwrite that because that is what the server wants. So what this graph shows is introduction of a new AVP in the OC supported feature header group AVP to indicate the abatement algorithm to be used for peer reports only. Okay, and again, I'll illustrate this. I'm sure good. I'm getting some thought process going. So good.
Okay, Steve. Martin Dolly, AT&T. See, I would assume that the agents have to be everything to everybody, and they would support both algorithms. Yes.
Most likely over time, yes. I mean, I wouldn't necessarily assume that at day zero they'll all support everything. But this is more. I mean, it may well be for instance, inter-carrier cases that one carrier prefers rate, the other carrier prefers loss, and would configure its nodes to do one or the other. And forcing coordination of what abatement algorithm is used across nodes in different carriers from different vendors doesn't seem like a reasonable assumption. Okay, next slide. So this is a question on application scope for the peer report type of DOIC. The scope, the applications that are impacted by a DOIC report are just the application indicated in the application ID for that transaction. That works for DOIC. It could work here. The question is, because we're dealing with agents here that generally deal with a lot of applications. DOIC, it works okay generally because servers support a small number of applications, clients support a small number of applications. The overhead of having to track DOIC isn't as great as it might be for this. So a decision we need to make is whether it makes sense to allow an agent or diameter node generically. I'm talking about agents here, but there's nothing preventing a server from sending a peer report. The use case that we're defining it for is for agent overload, and I don't know if anybody ever would from a server send a peer report, but it certainly would be possible. So we need to decide whether or not it makes sense to allow an agent to say, I'm overloaded and I'm overloaded for all applications, as opposed to I'm overloaded and I'm just overloaded for the application that happens to apply to this message. The benefit of allowing all all applications is less overhead on the previous hop, on the peer, on needing to track potentially statistics on messages sent per application in order to know how to handle abatement on peer reports. If it's single application, then and you have two agents in a row, and one agent is overloaded and it's starting to send overload reports. You may have overload state per application per peer that you have to start tracking, and the question is whether that's too much overhead, too much complexity, versus the consistency with the way DOIC is done. Is it better just to stick with the way DOIC has done it and deal on a per application basis? If you have any thoughts on that, hold them for now. Let me go through the ping pong diagrams, and we can come back and talk about this at the end. Okay, next slide, next slide. So I've got some ping pong diagrams. I want to explain the message nomenclature before I go through these. Okay, so for the OC supported feature header, what I've done is the first parenthetical indicates the source of the message, so the OC source ID header. The second parenthetical indicates the feature supported. So in this case, a client supports the
Loss algorithm.
loss. Thank you. Loss in the peer report type. Next slide. So in an answer, in this case, the answer was sent, this specific answer message was, or AVP was sent by the agent A1, indicating support for loss and peer, and indicating that the loss algorithm is to be used for peer reports. Then this OC peer algorithm that I talked about adding earlier. Next slide. In overload reports, the same thing. For if an entity supports peer, then it would send this structure of an overload report indicating the source ID and which report type is to apply to that overload report. And in this case, it would be peer. And next slide, just to show, this would be a historical DOIC AVP where we don't have a source ID, so it's just the load, the report type is all that is advertised or indicated and included in this AVP. Okay, so with that background, then we can go into the next slide. First use case is a pretty simple client-agent-server relationship. Next slide. And in this case, all of those nodes support DOIC and support peer. And what I'm showing here is the client supports DOIC and peer, so it's including the OC supported feature header, and it's including its identity in the source ID AVP, and it's indicating support for loss and peer. The agent also supports both. It's relaying this AVP, but it's changing the source ID to indicate support for, or to indicate that it was the one who included the AVP. And in the answer back, actually this is in error. Got to talk to it to really find all these errors sometimes, I guess. This should actually not in, no, this is right, I'm sorry. This, the server is saying, I'm the one that included this AVP. I'm going to use the loss algorithm for overload, and I also support peer. And then this is relayed down, and where the change by the agent to indicate that it sent it, but it's also including another AVP indicating I'm going to use the loss algorithm for peer reports. So when I indicate that I'm overloaded, look at this AVP. If the server is indicating it's overloaded, look at this one. Okay, so then the next step down, go through the same exchange. A1 becomes overloaded, so when it is sending answer messages, it will continue to do the same thing at the OC supported features as happens today with DOIC, but it's including an overload report now, and it's including an overload report saying that A1 is the one that included it, and it's using. Okay, this is an error. This should be L. It's the loss algorithm, and it's including any parameters for the loss algorithm, like the percentage reduction required. And just to show what can happen here, if both the agent and the server are overloaded, same exchange on requests. Server includes a host report. Host reports do not require source ID AVP, so it does not include it. Agent then includes its AVP for the peer report. So you have the two. You have a host and a peer report coming to the client. You know, that's a lot to absorb, but this illustrates most of the concepts that are extensions to DOIC. If you go to the next slide, I've got a textual description of that. And if you have questions, ask them as we go here. This is a lot to swallow potentially, but first note is if an agent indicates support for peer, then it must include the OC source ID AVP in all OC supported feature AVP groups, both in requests and answers. Right. Yeah.
Okay, so that was single agent. Are you going to talk about?
Yeah, I've got agent relay. So I've got the why we need support OC supported feature ID cases and yeah, and non-supported clients and that yeah. But the first point indicates that once somebody supports peer, they need to start including OC source ID in all overload-related grouped AVPs. If a node is going to send a peer report when overload, then it must include the OC peer algorithm AVP in the OC supported feature header. And then if a node sends a peer overload report, then it must include the source ID as well. So those are the two primary extensions, source ID for attribution and the new AVP to indicate what algorithm applies to this report. Okay, next slide. Okay, so this is if the agent doesn't support it but the endpoints do, and there's a couple of variants of this. Next slide. So this is the case where the agent supports DOIC, but it does not support peer. And in this case, the client has included OC supported features with an indication for peer. The agent can, based on policy, either relay it through unchanged or it can insert its own OC supported feature AVP. And the server needs to be able to handle both. In this case, in the case that it includes it or relays it, the server is going to recognize that the AVP did not come from the peer that sent it. So it can know now that the agent does not support peer and it does not need to advertise support peer in its response. So it's going to send a classical DOIC AVP. And because the agent doesn't support peer, it will never send a peer report to the client. Next slide. And this is a case where an agent doesn't support DOIC at all, in which case the agent will just relay the OC supported feature and OCOLR AVPs through without touching them, and everything operates as it does today with DOIC. Just included for completeness. Next slide. Okay, so the case where a client does not support peer, in this case, the agent that does needs to understand that so it doesn't send peer reports to the client. Next slide. Excuse me. Sorry, I walked outside the box. So this is not that interesting of a case, except that the client or the agent, in seeing that this OC supported feature does not indicate support for peer and does not include this clients as source ID, when it gets overloaded, it will not send an overload report. So it knows that its peer does not support this feature, so it does not send overload reports based on that fact. Where if the client, in the previous slide, client did support the feature, so the agent did send the overload report. The agent does continue to advertise its own support for peer, so it in this case has to modify the OC supported feature that it received from the client in order to indicate to the server that it does support peer. Okay, next slide. Okay, so this is a double agent case. Next slide. And in this case, everybody in the chain supports peer. So client indicates support for peer. Client is the source ID. Agent indicates support peer. Agent 1 is a source ID. Agent 2 is a source ID. In the response, server is a source ID all the way back. In this case, the agent is indicating support, or that the load algorithm will be used for overload reports. Now, when agent 2 becomes overloaded, it's going to include this overload report indicating agent 2 was the source of it, and that load, and then with the load parameters for the overload report. Agent 1 is going to strip that overload report because it does not apply to agent 1, it applies to agent 2. So this is the one piece of behavior that's required for agents not to proxy on an overload report that doesn't apply to itself. Receives an overload report from peer, acts on that overload report, does abatement as indicated by the overload report, but strips the overload report going to the peer, to the next hop. But if the server's overloaded, it does not strip, obviously, that server's overload report.
Okay, Martin Dolly. All right, so the scenario where these two so the interconnect point between the home and roaming carrier is between the two agents, right?
Right.
And let's assume there's some form of topology hiding. And so if there is an overload in, the server network, I mean, you're not going to give information about what of your servers are overloaded. And so have you given any thought to how that type of scenario would be covered?
Yeah, that's a good question. I mean, this is assuming all single domain, this slide here. And topology hiding really so far has been outside the scope of this group. So I mean, first you have to ask your question for DOIC without agent overload, without peer, because it's really this report here that comes from your server going to somebody else's client that you want to have proper topology hiding behavior, and on top of that, proper overload behavior. And I don't know if this is something, how deep we want to dive into this. This really is not an agent overload question. This is really a DOIC question, and if we want to address that here, we certainly can. I mean, I can speculate that this guy here is going to have to consume all of those overload reports internal to that network and somehow reflect them in an aggregated sense going out of the network. How that's done requires thought.
Okay, Martin Dolly again. I mean, that's the reason I'm bringing it up here, because in the pure DOIC sense, we weren't really talking about processing within the agent. Where here, we are talking about agent processing, and I agree with you that the agent's going to have to do something in that scenario, whether it be what you suggested or something else.
So I guess a question for the chairs. Do we see this as something that would be part of the DIME working group responsibility in general first? If so, this document? And if not, then does that imply another document to talk about DOIC in the presence of, or in a multi-domain environment, multi-carrier environment?
Yeah, Lionel. So first of all, we had this discussion already for the DOIC mechanism. The thing is that there is no existing definition of what is topology hiding and how this topology hiding anywhere is provided. So for the time being, it was assumed that it was something vendor specific, relying on the implementation of the agent, and it's up to the vendor to be able to provide this. So it's why it was not included in the scope of the DOIC mechanism, saying that if you want to apply that, do it in your way. The thing is that from the outside, the external world, nothing will appear, and how to manage it internally will be relying on your own implementation and operational decision policies. Now we could go forward, but first of all we would have to try to clarify what we call topology hiding and how to provide topology hiding, and I don't know if there is a willingness to go in this direction today, because it's more relying on the implementation of the agent and some functionality, but it's up to the working group to propose, and we will see what to do in this area. Martin, please.
Okay, so Martin Dolly, I mean, okay, not to draw analogies with SIP, I mean, but if you look at the discussions that occurred in the early 2000s in the SIP working groups, where, the box in the middle didn't exist, and back-to-back U agents were these fictitious little fairies that were deployed everywhere. And then eventually reality kicked in, and they recognized that these boxes are deployed, and they eventually called them by their name, SBCs. And so, I mean, okay, I'm happy either way. I mean, but I mean, you know, I think there is precedence within the SIP working group to recognize that, you know, though this occurs. I mean, even in dispatch earlier this week, there was a discussion about, you know, not revealing the IP. There was a discussion about providing a capability that would reveal the IP address of the originating carrier, and then that was viewed as being bad because of privacy reasons, right? And so the fact that information is streamed and not always shared is done almost in the pure sense with respect to, you know, privacy and protection. And so I think, you know, if others are willing to discuss it, I think it is worth discussing, because this is a realistic scenario.
Yeah, I would say that this, from an IETF point of view, it's okay because it is acknowledged that we have agent in the middle, and this agent can do some magic regarding how to do. But if we want to go for deeper in the details regarding topology hiding, we will have to define what is topology hiding from the IETF point of view. I think that the second point is related to what it is done in 3GPP, for instance, where the notion of agent doesn't exist except when there is a specific use of this agent for server location or for session binding, for instance, in the PCC environment. If you want to go forward, I think that this need to be also included as a 3GPP topic, because how to behave exactly regarding this in the roaming cases, for instance, will depend on the type of application. You will have to decide which, it was the same for SIP, which kind of information you would like to pass over the roaming interfaces or not. So I think that this work will not be done within IETF, but within 3GPP. At least what we could assume here is that this information may be discarded by some agent, and this information may not be available to a downstream node.
Okay, I'd like to hear the views of others, because I think, you know, no offense to 3GPP, but 3GPP means you're going to go back to SA2, and I don't want to deal with that hell. And so therefore, AT&T would much prefer it discussed here if that's possible.
No problem.
I think the critical point as far as this discussion right now is that in order to talk about topology hiding, we need a definition of topology hiding, and if we do deal with that in this group, I would think we would deal with it separately and have that topology hiding be base diameter post-doig, agent overload, all those things combined as a separate thing, not as part of the agent overload spec.
No, but I think that one of the valid comments from Martin, for once, it's that we have to assume that this information, even if provided by a server or by another agent, may, even if both are supporting the information, may not be forwarded to another node. So I think it should be assumed why and when. We don't have to say that, but I think that this is something that could be stated in the document.
So you're suggesting something along the lines of that if policy indicates that the previous hop is in a different domain, you might strip this, something like that.
For instance, and it would mean that we go back to any other scenarios. For instance, it would be like the client doesn't support, or this information is not available, or whatever.
I'm not sure that belongs in this document. That's just a truism. You know, if you don't want to forward ABPs because of security or privacy reasons or inter-carrier reasons, don't. But that doesn't need to be certainly not a normative statement. I mean, it might be a descriptive thing.
Yeah.
But,
Okay, please go on.
So we can talk offline, Martin, about whether we want to bring something forward. Okay. Yeah. So this is a case where the rest of these should, as you read these slides a second or third time, really aren't showing much new, but what'd you do to me?
It was 15 minutes.
Oh, you got to give me some.
So
That's
please,
because Martin took
please
all
speed
my
up,
time.
yes.
Yes, actually, I have a comment about the previous presentation. It's about, perhaps you can go to the single agent slide, I think the 14, where you introduce the source ID IVP. It's this one, the flow.
You mean this one?
Yes, this one, yes. If with the DOIC, we can have the client and the server to be the reacting and the reporting node. But if for the agent now supports the agent overload, from what you introduce, it seems that de facto it means that client and server, it is acting as also as a reacting and reporting node for the DOIC OLR, the DOIC flows. No, because we have the source ID that is introduced, and you say that the OC feature now it's between even for the DOIC.
No, no.
It is between the client and A1 and between the. So I have a bit of questioning. Perhaps it can be a bit further analyzed outside here, but it's this relationship between DOIC and agent overload. For me, agent overload is rather independent of the DOIC itself. It's something we had, but both of them can be managed independently.
So this does not change anything about the way DOIC works, except that because you support peer, you also have to put source ID in all of your message exchanges relating to peer. So all OCs, if you support peer, then all OC supported feature AVPs will include the source ID, both for requests and answers. But supporting peer does not mean that you have to put a source ID in a host report. You know, that host report coming from a server is the same with and without peer, with or without supporting a peer. If you're sending a peer report, then you have to include the source ID, only then. So it doesn't change anything about the way reporting nodes and reacting nodes work in classical DOIC, except, as I said, with the OC supported feature header. Okay,
Yeah, another way it would be to say that even if the OC source ID is present, it's only applied to the report type peer, and it is ignored for the basic DOIC mechanism.
that's also true, yes. Yeah. So it only applies to the negotiation on peer. Yep. Okay, keep going. I'll just do one more of these. The next topic will go much faster than this. Next one. This one here. Okay, so this is a long agent chain where one of the agents in the middle does not support the peer mechanism. Next slide. And this hopefully illustrates what happens when this agent doesn't support DOIC, so it's going to proxy through this AVP, which has an attribution of A1. When that attribution of A1 gets to A3, A3 is going to recognize it's not a peer because it knows its peer's ID is A2. It gets an AVP with an attribution of A1, so it knows that A2 does not support it. So when it gets overloaded, it will not. This is. I was actually going to use this as a test to see if people saw it. When I saw it this morning, error in this morning. This AVP should not be there because it detected A2 did not support it, so it's not going to send a report. So I apologize for the error in the slides. So based on the fact that A2 doesn't support it, it's not going to include this. If indeed it does, the fact that we are also including the attribution in the overload report, A1 can know that this overload report did not come from its peer, and just ignore it, just discard the overload report. So hopefully that gives everybody a feel for what agent overload, what the agent overload solution in this draft is documenting. Go to the next slide. I think it's the next step. So the next step is to get people to review the draft, review and comment on the draft. So.
Okay. Thank you, Steve. Any additional question on this document? Actually, one question was regarding the scope of use of this report type, new report type. So is there any comment on that? Or so just a question for clarification. It was for all applications, because in the slide it was said transaction and all the transaction, but when you mean that, it's for all the application or for one given application?
Yeah, the question is, does it work like DOIC where the reports only apply to the application indicated in the message, in the transaction, or if I include the overload report in an answer message, does that apply to all application messages going to that next hop?
And have you also considered the fact that if it could be one or the other, would it be possible to have both?
Yeah, that would be the middle ground, adding an ABP to having the default being it just applies to this message, and add an ABP to wildcard application support.
Okay.
Yeah. That might be the right way to go, and let the implementations decide which is the best. Yeah.
So.
Hello, planning integration networks. I would prefer to use application ID specific P reports, because in the client you may have a distributed system, and in a distributed system you process different application in different parts of the system, and you do not have a centralized control for that. So it would make more sense, application-specific reporting. That's all. Thanks.
Okay, so that would imply that you wouldn't actually want an agent to be able to send all, just a single application. Okay.
Okay. Who has reviewed this version of the previous version of the document? 3, so Jean-Jacques maybe? And no? So who is volunteering to review at least this version? Because we need to have formal review of this document, because now it's a working group document. It was formally adopted last week, the last meeting, so we need reviewers. So who would be volunteer to help Steve? So saying that to review the document, to comment, propose some text if needed. Martin? Okay. So please send as soon as possible your comment on the mailing list. If needed, we can, as we have done for the DOIC mechanism, we can even set up a specific conf call for that. So please send your comment on the mailing list and try to initiate a discussion on this working group document. Okay? So next was the load consideration?
No.
Not yet?
The rate algorithm. Load's not a working group item yet, so we're talking about the ones that are.
Yeah, for sure. So enjoy.
Okay, next slide. So this is the rate algorithm. As a reminder to people, DOIC currently supports a loss algorithm, which is basically saying reduce traffic sent to me by 10% or 20%, whatever that value is. Rate is giving the overloaded node the ability to say, send me a specific amount, no more than a specific amount of traffic. So send me 100 transactions per second or 2,000 transactions per second, whatever it is. And the reacting node then will handle abatement accordingly based on a specific rate, rather than based on dropping a random or a specific number of requests. Updates in this version, again, were primarily for consistency with DOIC, and then also consistency with RFC 7415, which is the SIP rate control document, and then some editorial updates. Next slide. Let me talk about SIP first. there's been significant work put in by the SOC group, which is now closed down, in defining this rate algorithm. The algorithm itself, leaky bucket based approach, is specified as one approach that somebody might take to implement the rate algorithm. That's by no means prescriptive. If somebody has another way of ensuring a certain rate of messages are sent, then that's certainly acceptable, but this gives one example way of doing it. And so what I took, with the author's permission of the SIP draft, in fact, is co-author on this draft, that Eric Knoll from AT&T that wrote that portion of the SIP draft. I modified it to change all the SIP UA to diameter client server, from headers to AVPs and all that kind of stuff that are different between the two protocols. Other than that, it's copied verbatim from the SIP rate RFC. This is background. So this draft has a dependency on the previous draft that we talked about, because one of the uses for peer will be, for rate will be use of peer reports. So the server can tell an agent, or previous hop, what rate to send it, and agent can cascade that down back towards the client. That's one of the uses, one of the scenarios. Next slide. So the question on report types support, as I said, one of the report types that could be used, that the rate algorithm can be specified in is peer. The current draft also says that you can include peer or rate in host reports and in realm reports. My question is, does it make sense for both of those? I talk about realm reports first. Does it make sense to have a realm report specifying a rate to be sent to that realm? I am not sure that makes sense personally, but request sent, realm router request sent to that realm.
Yeah, it makes sense to use rate control in realm reports, because sometimes you have a server that is also distributed, but it's looked at as a whole realm from client perspective, but it's a single machine, so to say.
And wouldn't that server then send a host report instead?
I think it's a configuration issue or an implementation issue. So if you keep this door open for the implementers, then they can use both.
Right, okay.
And that's also,
good
for my point of view, it's also true for the host reports, to be able to use rate control in host reports, because you mentioned in the draft that it can control the rate, that the increasing rate more better than the normal report, this loss control.
Right. Yeah, I can see the case for host report much more clearly than for realm, but that's why I asked the question, to see if other people saw the need for this in a realm report, and if so, then the draft will stay as it is, indicating that rate can be used in all three report types. Yeah. Next slide. Are there any other comments on that? Okay. Same thing on algorithm applicability. Oh, no, this is different. Yeah, I'm sorry. The algorithm specified, as I said, was pulled directly from SIP. SIP does not have the same concept of a differentiation of request types, realm routed and host routed. So a little bit of thought needs to be put into whether the algorithm needs to be updated to reflect the fact that some requests are going to be source routed, basically, and so you have less flexibility on what you can do with those versus others that are realm routed, and you can take different paths and end up at different servers for those as well. So I haven't thought about this a lot, and so I'm not sure we can talk about it here without some in-depth thought, but we can take initial comments if anybody has any, but this is something that needs to be resolved going forward.
Sorry. Just a question for clarification. When you said the rate algorithm need to be updated, you mean the rate algorithm as defined in the SIP document, or?
Which is also the rate algorithm defined in this draft.
Okay.
Yeah.
So
with-
for the time being, there is no differentiation between realm and host, and you are considering the fact that you may introduce this difference?
Exactly.
Okay.
Exactly. Yeah, it just talks about requests now. Okay, so that we'll just leave that for follow-on discussion. Next slide. Okay, so as I said, the peer draft needs to progress one step ahead of this. But we can certainly do them in parallel. So the same call for review and comments on this. And I'll start this discussion on the question that on whether the algorithm applies or should be differentiated based on host and realm market requests.
Okay, thank you. So and this document has a working group share comment. This document is also relying, of course, on the publication of the DOIC mechanism, because it's relying directly on the DOIC mechanism. So it will be an update of the or we use the DOIC RFC as a reference for this one.
Yes.
And another question would be that you said that there is a link between this work and the agent overload document, but I was wondering what would be also the link between the current work on the load mechanism. Have you considered the link between this work and the load, and is there some alignment to have or whatever?
I don't think there's a link. I don't think there's, I mean, other than similar things being reported on, I think overload and load are two completely separate things, as we'll talk about in the next presentation. So I don't, if you accept that, then there's no link between rate and overload. But
Okay, so Martin Dolly, all right, so I agree with what Steve said. I mean, so you use load information to redistribute traffic prior to overload. Once you're in overload, can be very dangerous to redistribute traffic, because all you're doing is taking a problem from A to B. And so how you redistribute traffic pre-overload versus in overload are two different things.
It's one way to say that, but I think that we can discuss. But for me, it's not so clear as soon as we speak about rates, what will be the meaning of this information sent to the downstream nodes. But it's something that needs to be considered, because here there is the only thing that you say, or maybe it is already clarified. I have to check again. But the real meaning of this information, what does information mean? As soon as you send, please send at this rate.
Okay.
Yeah.
Okay, Martin Daly, AT&T. Okay, so within SIP, there was an extensive period of time where there was modeling done, performance models, simulation models done by individuals to come up with the same result. And there is distinct difference in behavior between a rate algorithm and a loss algorithm. When it comes to protecting against storm surges, like you would see with registrations toward an HSS, a rate algorithm is a lot more effective than a loss.
I do not challenge that, Martin. It was more about the link between rate and load, not overload. So, but I think that
and just address that real quick. Rate is talking about transactions per second, or messages per second. Load is talking about percent resource consumption. They're two different values. Now, one might lead into the other. There's correlation between them, certainly, but I don't think there's a tight coupling.
Okay. Anyway, it will be part of my duty to review the document and to comment if needed.
Yeah, if I'm wrong, then you'll tell me.
So same question for this one. I think it's quite related to the other one, so I expect some hands also, but who is volunteering to review this document also? Okay, so same batch of people, plus Yoni, I think, and me. And so it's okay for this one, Steve? Just for the blue sheet, do not forget to sign the blue sheet for people not already on the list. So I think there is two, but so next one would be the. So you are responsible for the agenda. So what is the next one?
Well, the agenda's going to load.
Load information. Okay. So this document is not yet a working group item, but we have a, so it was already presented at the last, so the first version was presented at the previous meeting, and Steve, on behalf of Ben, but now you are the editor of the document, will present this document. So the update of this document.
Yeah, Ben apologizes that he can't be here, but he's in the M-Music meeting acting as RI AD. So he recruited me to replace him. So you get to hear me talk for another couple of slots here. So this is the load. The topic is load, which is one of the things in the overload requirements that was addressed, but was delayed or postponed as part of the DOIC work. So this document does not propose a solution. What this document does is talks about considerations that need to be factored into the design of the load mechanism. And Jean-Jacques is also a co-author on this. He contributed a significant amount of work on analysis of topology use cases that can be used to factor into this design process. So next slide. So first question, what is diameter load? And both Ben and I had identified some discontinuity between the way people were talking about load in the past, so we wanted to make sure that we had consistent definition of what load is as opposed to what overload is. So basic concept is load is the current state of a non-overloaded node. I currently am using 60% of my CPU, disk I/O, whatever resources are important to me as a node in the network. That's what load is, and it's used at a minimum, it's used in peer selection, where load balancing between peers can take the load value of each of its peers into its factor that into its message distribution algorithm. Now, the interesting thing with diameter that I think is covered elsewhere as well, some of the requests, if it's an agent that's doing peer selection, some of those requests have already had the destination selected. So if it's the last hop agent, it can't use load information to distribute that message because it's already directed to an individual peer. But if it's not the last hop agent, it can, because there may be a couple of agents that have a route to that server that's indicated in the destination host AVP. So that's just one of the things that we deal with in diameter. Is a little different that we struggle with for a while when we're talking about DOIC. So load information is used for load balancing, hopefully to help avoid overload in the first place by not sending everything to one node until it gets overloaded and then start rerouting. There's potential that we need to talk about on generic server selection when the server is being selected by somebody other than the previous hop or the last hop agent, which is certainly something that's done today. It is different than overload. Load information, it's information that's used by the recipient as needed. It's not mandated that somebody must do something. It probably should, but not a must. Where overload is a request for an action. I'm overloaded, you must do something about it. You must help me here. Load is, here's some information about me that you might take into account when you're making decisions in the future. And high load does not necessarily imply overload. You might be able to predict that overload's approaching, but it does not indicate that overload has happened. Next slide. So first, before I go on, does that make sense to people? That very high level definition of what load is. It's different from overload. It's It's a indication of where I am, but it's not asking for any specific actions from the previous hop. So the topology of load, the draft, as I said, contains a number of topology use cases of different network topologies to use to evaluate some of these decisions that we needed to make as outlined in this presentation. What it boils down to as far as the basic topology of how load information is used, you have a number of alternatives. It can be just between peers. That we could say that load information is only used for load balancing from a peer to the next hop. We could say that it's just between endpoints, that a server advertises this load and only endpoints act on it. That one I think it's included for completeness. I don't consider that a viable option, but the next one that we need to talk about is whether both make sense. Does it make sense for a server to advertise its load and for that load information to propagate itself down through the network all the way to the client? Are there cases where other nodes, other than the previous hop, can use that load information in a valuable way? And that's I consider an open question right now. This last one, between any arbitrary nodes, early on in this effort, there was a number of proposals for both load and overload. One of them from one of our illustrious working group chairs was an application for subscribing to basically load information, and in that model, anybody could subscribe to anybody to get the load information and receive updates on load. So that's kind of the concept between this load can be sent between any number of arbitrary nodes. If we went with an application, then that would be enabled. Okay, next slide. I'm asserting that support for peer load is needed in discussions we've had. I think so far indicate that that's the case, so that this load balancing from one peer to the next hop use case is supported. And then the other case is whether we need to also support it where server selection is. Do we need to support it where server selection is not done by that last hop agent, as I said before? We need to determine if there are scenarios where endpoint load is also needed. So that's stating the same thing. And we have an open question on the impact of interaction between load and redirect agents. When a redirect agent sends a set of servers presumably that have potentially load information about what happens, and that case really hasn't been talked about yet, or thought about much yet. Next slide. Okay, so I've got some preliminary recommendations in here. They're mostly Ben and I's, and to some degree Jean-Jacques agrees with some of these. Some of them he might not agree fully. So they are preliminary. They're meant to stoke thought and conversation and hopefully move us forward. It's highly likely that some of them are wrong, and if that's the case, then we'll change them. But just to try to put a preliminary stake in the ground in some of these. So one recommendation is support for peer load reports. Any node can send load information. Agents can optionally aggregate load information. So when an agent sends load information, it can presumably reflect its own resource usage, but it might also reflect the aggregation of the servers behind it or the network behind its capabilities. Open question on if we talk about this aggregation, does the agent indicate two values, its own status and status of the network behind it? Does that make sense, or does it include one? And then there's also the open question of if we talk about this aggregation concept, do we include normative behavior about it, or we just say the agent can, if it wants to, reflect the network load status as part of its load status. So some questions for contemplation. And then optionally, add support for endpoint load reports, and this would be the case where a server says I'm loaded at value X, and that report goes all the way back to the client, and any node in the network can use it for if it's doing server selection. This does add complexity. It requires carrying two load reports, one for the previous hop and one for the endpoint, and there's some management of what to do with those load reports by agents on a hop-by-hop basis. We are recommending that the general non-adjacent node reports are out of scope. So like agent in step 1 in that long chain cannot get a load report from an agent 2 hops away. We don't see value in that, and the complexity of that would be significant. Okay, next slide. Scope of load information. Does the load value indicate load of the entire host, load of an application at that host? Do we have the concept of load of a realm? Same questions that we've been talking about with DOIC in some cases. Do we have the defined concept of load of a group of hosts? This overlaps with the aggregation concept, where an agent may be acting as a server front end, is a term we've used in discussions before. For some number of servers, does it make sense to support the ability for that agent to independently report on that set of servers from its own load? If we do, the more of these we do, the more metadata we need to describe the scope of the load metric. And that could either be, as we've done in DOIC, some of that metadata is implicit, meaning it's carried in other pieces of the request, or it could be explicitly indicated in a set of AVPs we define. And if there are questions as I go through, please ask them, or we can at the end, either way.
Yeah, Martin Dolly, I think with respect to your questions, I think it would be useful to maybe describe use cases, and then based on the use cases, derive the merit of passing and then processing additional information.
Yeah, and to a large degree, that's what we've started doing with the topology scenarios that Jean-Jacques identified, and it's these set of questions that we're kind of, whether we're consciously doing it yet. I am consciously doing it. I'm not sure everybody else is yet, but that's the kind of decisions that we need to make as we walk through those. Yeah. Okay, next slide. So preliminary recommendations here, just again to foster conversations, that we do not address the concept of realm load or the concept of a set of hosts, the server grouping concept in the initial draft. That we focus on single node, the single node case initially, and then if we identify the need for others, we identify that as follow-on work. And the next one is that we be consistent with DOIC, and that load applies to an application at a node, not all applications at the node. We could do the same thing we talked about with peer and do both. Have the default be it applies just to the application in this message, and have an AVP to override that if we want. Open question. Next one is that the AVP, there's an AVP in the load report that indicates the source of the load report. Similar to what I talked about with the peer report case. So something like a source ID AVP. And then optionally, if we want to extend beyond individual application, optionally having an AVP indicate that this is a load report that applies to all applications, not just one. Okay, next slide.
So you will have the question will come later, or we
You can ask questions now. Yeah, you can ask questions now if you want.
Okay. For instance, for this one, for the load information about either one application and all application, do you expect a change of the behavior of the node receiving the information? For instance, if it is assumed that the load information, saying that, for instance, the load information is sent in all the answers and requests, or any message. So what would be the difference between having the same load information sent for all the application? That means that this would be applicable for all the application, but actually you will have one information per application.
Well, there's the possibility that a node could say for application A, I'm 10% loaded, and for application B, I'm 20% loaded.
Yeah, but if you are saying that, for instance, this information is valid per application, you still have this possibility. You still have the
If
possibility.
it's per application, you have that possibility. If it's all the same, then the node receiving the load information does not have to have separate queues for separate load balancing algorithms using different data for each application.
Okay.
That's where, so if you say it supports all applications, I think it means implementations can be easier. But I'm not sure that it's worth mandating that. And then if one node expects to receive it on only application, and another node expects to only send it on all, then we have an interoperability problem. So we do need to specify it one way or the other.
Okay. Thank you.
Precedence between load and overload. So how does two sets of information interact? Preliminary recommendations. Overload information takes precedence. It is asking for action. It's a exceptional situation. So if you get an overload report, you take action on it independent of what load says. And then also an indication load does not imply overload. 100% loaded node does not necessarily mean it's overloaded. It can be saying it's 100% loaded and not ask for overload abatement action. Same with 0% does not necessarily imply that it's not overloaded. May seem strange, but there's no reason that we should prevent that. But load could be used as an input, obviously, to protect and prevent overload. Jacques.
Yes, about overload takes precedence.
Who are you?
Sorry?
Who are you?
Jean-Jacques Trottin, Catalyst, sorry, I have to take some of it. About overload information takes precedence, I think that I come back on a remark from Martin about it's true that overload information takes precedence, but what is the impact about the traffic redistribution? And perhaps we should have some focus about the traffic redistribution when we are in overloaded situation, relying on the load information that can exist for other nodes which are not overloaded, but we have to. Do you see what I mean?
No, I don't. Not yet. Try again. So you get an overload report.
I think we have the load information that is coming from various nodes which are not overloaded, so we are doing load balancing and so on. Now load overload appear on some point, and then a question we had in overload is how to redistribute the traffic. But we have also to pay attention about that, not to overload all the whole network. And so here there may be some behavior aspects related between the overload information get from overloaded servers and the load information got from non-overload server.
Right,
So at that point I want to have some focus on this.
Yeah, let me restate, make sure I understand, but I think the case is if an agent, for instance, is routing requests to 5 servers, one of them is overloaded, the other 4 are not, you're still going to use load information to understand how you distribute traffic over those 4 non-overloaded servers, right? Is that an accurate summary of what you said, Jean-Jacques? Is that close? So you're not going to ignore load information for servers that are not overloaded. Okay, next slide. Okay, so back in the box. Question on semantics. The 3 drafts that existed before had 3 different levels of granularity in specifying load. one from 0 to 10, one from 0 to 100, and one being consistent with the way the DNS SRV is defined, being 0 to 65K. We don't need to decide this now. It's just something we need to specify. The advantage of going with the DNS approach is that it's consistent with other load balancing mechanisms specified in the IETF. Next slide. Question on negotiation. Obviously, in DOIC we have negotiation on feature capabilities. Does that make sense with DOIC or with load? In talking about this, the only case where that I can come up with off the top of my head that it makes sense to know that the previous hop supports load is you could then use that to not send load to that previous hop, which then would allow you to know that your load information is not going to leak beyond that previous hop. So it might be a topology hiding related, inter-domain carrier related scenario where you want to know that you would only send load information if the previous hop supported it, because you know that previous hop, by supporting load, will strip it and not send it. Will not send it on. Now that what I just said assumes that load is scoped just for peers. That does not apply necessarily if load is scoped for the endpoint load that flows all the way through the network. So anyway, next slide. I think I have a preliminary recommendations on this. That we do not support a negotiation mechanism. We do have a source ID AVP included in the load information so that a receiver of that information can know whether it applies to the previous hop. If we support the endpoint information, we also would then have the ability to have two in the report, and you'd have to be able to differentiate them. And one would have the source ID of the server, the other would have the source ID of the previous hop. And then the leaking load information scenario would be handled by topology hiding implementations, and would come back into the conversation we had earlier about handling topology hiding. It would just be a requirement, whether formally specified in a standards document or informally specified in GSMA or specified in vendor requirements documents, that load information not leak out across that carrier boundary. Next slide. By the way, I might go a little longer than 15 minutes on this one, but I'll go shorter on the next one. So hopefully I'll make up the time if I go long. Transporting load. The way we transport load information in DOIC is piggybacking. So that's one option. We've also had the proposals to have a dedicated application for both. In that case, it was both load and overload information. In this case, it would just be for load. So that is an option where you could define a diameter load application and have some kind of subscription mechanism, and then only thing carried by that application is load information. There's also, if we want to really throw the net wide, there are other subscription notify pub/sub-ish type implementations that we could use if we wanted to. I don't think that makes sense in a diameter working group to define a SIP events mechanism for carrying diameter load information, but it's there for completeness. So next slide. The recommendation is that we do like we did with DOIC and just make it piggybacked, set of AVPs added to existing application messages. But it is not part of DOIC. We would support the ability for nodes to implement load and not implement DOIC. Mark will decide whether that makes any sense or not, but we don't. But we keep we don't tightly couple the two. We can progress load independent of progressing overload. Okay, next slide. Okay, so frequency of sending load information. This came up since the first draft of this document. Question is, do we follow the DOIC kind of an approach where the baseline assumption is that load information is sent in every request? Or do we define a mechanism that allows load information to be sent once every period of time, or only when the actual load value changes by some percentage. I think if you try to say that only when the load value changes, that's going to be effectively always, because depending on how you calculate load, if you say any change, even small changes, you're going to probably send it a lot. But you could potentially say that one approach would be send load information only when the load value is changed by 5%, or something like that. Question is, if we do this, then does that introduce the need for negotiation as well, where the receiver of load information can say, I only want to receive it once every 5 seconds, or I only want to receive it only when it changes, or whatever approach we take, and then the sender saying either okay or no, I'm going to override you, I'm going to always send it, or how we'd have to work through that kind of scenario.
Martin Daly, I think here we ought to just keep it as simple as possible. Stay away from negotiation. The node sending the load information should not make any prejudgment on whether it's going to be used for processing in a downward node whatsoever. I think that sending it in every message would be okay. I think implementation dependent on the receiving or recipient node on, if there's a change of blup, then it reacts, so you don't want this to be processed you want to minimize the processing of this information.
Well, and that would be one reason to say you can only don't have to send it in every request. The receiver of it, if you send it in every request, has to parse it in every process and parse it in every request. I mean, could choose not to, I suppose, but
you can also have so on the receiver side, you could decide to take into account only one message or one load information per 10 message, for instance. So I think it's keeping the flexibility will allow the receiver to do whatever he wants with this information. He can even ignore always this information if there is nothing to do with this information.
yeah, that's very true. The receiver can always just sample once every period of time, and then ignore those AVPs for the rest of the time. But if the receiver is doing that, it's depending on the sender always sending it. If the sender is implementing an algorithm, I'm only going to send it once every 10 seconds, and the receiver is implementing an algorithm, I'm going to listen only once every 10 seconds. Without those two intervals being synced, then the receiver will never receive anything.
Yeah, my assumption was that this information would be available in every message.
Right, okay, good. I think that was the recommendation also. Well, I think I said TBD, because we really hadn't. Okay, so here are the alternatives.
Sorry.
And the next slide. Okay. Yeah, so I left it TBD. I think my thoughts are consistent with what we just said. The sender always sends it. The receiver can sample as frequently or not frequently as the receiver decides. Yeah. Okay, next slide. Okay, so summary of these recommendations. We support peer reports, and we need to decide whether we also support what I'm calling here endpoint reports. We have to decide on whether how much we specify the concept of aggregation of load aggregation of server grouping, or the network load of the network beyond an agent. Any node can send load information. We have attribution using a source ID kind of concept. Load and overload are separate. Load metric is scoped to an application. TBD if we also support the ability to mark this as for all, although I suspect probably not, just avoid the complexity. Piggybacking for transport, no explicit direct declaration of support, and then frequency based on what we just talked about of sending the information. So, again, these are preliminary recommendations. We're still going through kind of the analysis of the different scenarios. If we identify any of those scenarios, then these could change. Hopefully those scenarios will help us understand whether we need this endpoint report concept, and we'll identify some of the other use cases or some of the other design parameters that we need to work through. Next slide. Any questions or comments on that so far?
I have one question. So regarding the first point, it is so we need to decide if we may have load information regarding endpoints, right? So depending on this, the source ID may be or may not be required, but at least if we define the source ID, we'll let the keep open to further.
I think the source ID is required either way, because you need to know whether the load information came from your peer or somebody. If your peer doesn't support load,
Right.
it's just going to proxy it through.
Yeah.
So.
At least to ignore it or.
Right.
Okay.
Right.
Thank you. Further question on this list of primary recommendations? So next step.
Okay, so next steps. This is not officially a working group item yet. I mean, it was kind of implied by the fact that it was in the requirements that were accepted, but the document is not on the working group milestones yet. This document, by the way, in my mind, this document dies, and another document that actually defines the mechanism comes along. This document is architectural considerations. We could keep it under the same name, this is an administrative thing, but mechanism draft. There's no mechanism in this draft. We need to define the mechanism separately, presumably separately, or we just add chapters and delete chapters, however we want to do that. But we're asking for the work on load to become a working group item, and then work on defining that mechanism.
Jean-Jacques, please.
Yes, I also agree that we have a separate document for the normative part, because this one is informational in any case. Now, I would not say that it will immediately die, because if because I think that is raising a certain number of questions. We can have some updates. It doesn't prevent us to do the work on the normative part in parallel, but but this document is quite helpful to see what the consideration we dealt with and what were the conclusion we had, and that has not to be reminded in the normative one.
Yeah, when I said this document dies, I mean it probably doesn't progress to an RFC status. I mean, it'll still be there for us to use as we define the normative behaviors, but I wouldn't see much of this information does not need to progress to an RFC status. But others could think differently, that this would be published as an informational RFC, but it's really kind of a first step in the process more than something that would be an endpoint.
So at the last meeting we had the same discussion about what should be the future of this document, because I would say that even if it is a separate document, this document will be only linked to the related mechanism defined. So it could be merged actually. And I think that the things that we could do is to try to clarify what needs to be clarified regarding the use cases and so on, to remove everything that is not strictly needed in this document, and to define the mechanism along this one. So I think that we have two alternatives. And having a separate document only for the use cases is not so relevant, because we will need to take some assumption on what we would do for now, and the mechanism defined will be based on this assumption. So I would like to link both information in the same document, because I think it will be more relevant, because otherwise we will have one informational document, for instance, and how to use this document after that, I'm not so sure that it will be so useful, because we will rely on the specifications. So from my point of view, there is no problem to put a lot of information at the beginning in the document, and to remove after that when we have a clear decision on where to go and what to define as the mechanism for load information exchange.
And I'm good either way, it's just we need to decide how to move forward.
Okay.
My assumption was that it would be two separate documents. The depth of review is affected by that decision. If there's information that's in this document that's going to carry forward to RFC, then that needs to be dealt with maybe a little more carefully than if it's temporary information.
Or maybe, as you said, you could say that we could work on this document, and as soon as we have something clear, to extract what it is needed in the mechanism and to let the document die.
So the next step may well be to come up with a table of contents structure for the mechanism document, identifying which pieces of this document carry forward and which ones don't.
Okay.
Yeah. Okay.
So we have several questions right now, I would say. So we have discussed this at the last meeting. So first of all, it is something coming from also the DORIC requirements RFC, where load was indicated as a requirement to support in the overall for the overall solutions. So I think it is really linked to this requirement document. So there is a need from a working group point of view. So the basic question would be that do you agree to adopt the load control topic as a working group item first? So people willing to see this work progress in the working group, please raise your hand. Okay, sorry, you said 10? 8. And people that don't want, that doesn't want to see this, to progress this work in the working group. Don't be shy. No one, so 8. I think there is a support for that. Of course, for all this question to the working group, we will publish it on the mailing list also. So formal call for adoption. So first, so the work item is agreed to add as part of the charter of the working group. At least this is along the requirement document anyway. Now, should we adopt this document as basis for future work, that is as a working group document? But we will have to decide what to do on this one. So first the question to Steve. If we agree to have this document as a working group document, we can decide to work on this one. I think I will ask, so maybe you were not there. We have a document where there is a set of consideration regarding use cases and assumption on the type of mechanisms that we need to define. But it is foreseen that this document itself will not be so useful, so it is not intended to be progressed as a working group document at the end for, until the publication and the RFC, but to reuse maybe some part of this material in a new document that will define the mechanism itself.
Kathleen Moriarty. So yes, that sounds like a fine approach.
Okay.
Thank you.
So my proposal would be to ask for formal adoption of this working group document, this document as a working group document, to work on this document, so to try to remove all the TBD in the document and to provide the maximum of details, and to decide what to keep along the mechanisms that we, so the specification that will define the mechanism. So it's.
So just to be clear, we're going to turn this document into the mechanism document, or we're going to progress this one and have a separate mechanism document going in parallel?
I think
don't
that
care either way, but
exactly, because there is nothing preventing to add a new draft with a new structure and so on, but we can still progress on this working group document. And we can decide what to do with this working group document as soon as either we have a separate draft or we want to merge all the information. But I think that we need a place for discussion and to progress on this on the load information exchange.
If we kept, yeah, I agree. I mean, we could actually come in and have multiple mechanism drafts submitted and have the working group choose between them if
yes.
I don't foresee that happening with this.
But I think that all the assumption we need to be so we need to agree on all the assumption regarding the working assumption regarding the definition of the
Right.
load mechanism anyway. So the question, so Jean-Jacques, yes?
As an example, for example, load metrics, you have defined 1, 2, 3, 4, 5 load metrics. Do you think that we have to remind this, it is part of this document and we have to state which load metrics we will finally identify as relevant? But I do not think that this analysis of load metrics should be copied in the normative document.
Yeah, I think we could certainly have an appendix in the normative document that pulls from this document, or this document becomes a mechanism document, one way or the other.
Just one clarification, Jean-Jacques. There is no normative document. You have a document, and in the document you will decide what is normative and what it is not. So it's not like in 3GPP. But I understood what you said. But this kind of consideration could be. We can rely on the working group document to see on this document to see what to do with this information inside. So. The question is that who would be in favor to adopt this document as working group document, and as I said, it will be a basis for future work. So the same set of people would say 8, if I'm correct. And who will not support the adoption of this document as a working group document? 0. So this will be confirmed on the mailing list, but the basic assumption is that this document will be a working group document. Okay? Thank you. You want a glass of water or? So next, it will be the message priority. And should be, yeah. So this document is, so it's the first presentation of this document. It was, I think, published at the beginning of the year, recently, this document.
Yeah, it was January or something.
And Steve will present the purpose of this document. So please, Steve.
Okay, so this document came out of discussions with various people about DOIC and implementation of DOIC in various networks. There was a realization that, and no surprise to anybody, but there's a realization that DOIC does not have the ability to differentiate between individual requests. You go to the next slide.
Sorry.
Next slide. With DOIC as it is today, you get a set of requests, and if you're abating on those requests because of overload, all requests are in essence created equal, and all requests thus have the same priority of being dropped or rerouted depending on what the abatement behavior is. So this document attempts to define an end-to-end mechanism to allow for nodes in the diameter network to factor in a priority when making routing decisions and when making overload abatement decisions. Next slide. By the way, the draft as it exists today is structured to eventually become a mechanism draft, but it right now just has a set of questions, and what I'm looking for today is feedback on whether the DIME working group would be interested in taking on this work, and if so, then my thought would be that this draft would eventually become the mechanism draft, but that's a few steps away before that happens. So DRMP, diameter routing message priority, basic use cases. A lot of this has been talked about from a call processing perspective in SIP and various other places already. We have first responder emergencies or natural disaster related scenarios that have been talked about, hurricanes and tornadoes and such things. You have emergency call related scenarios where, in both of those cases, presumably the behavior would be to have calls related to, or I would say even more generically, network access scenarios that related to those first responders or for those emergency callers having a higher priority than other people in the network. And so that if you have a limited number of resources, or if you have a node that is overloaded, and you're routing requests from emergency responders versus mothers and daughters that are panicking about what happened in the emergency, those emergency responders would get preferential treatment. Sons and fathers, I guess, would probably get panicked as well. I didn't mean to imply that anything otherwise. There's also scenarios potentially where an operator would want to offer differentiated services. An SLA kind of an environment where if you pay enough money, you get higher priority when it comes to routing decisions or overload abatement decisions based on that SLA. And then there are actually some application-specific prioritization that might make sense, where, for example, given to me was an S6A, where the ULR priority might be marked as higher during an MME restoration process than for initial attaches. So right now there's no way of signaling that, so that a proxy or an agent in the network would know that this same application request type ULR in one case would be given a higher priority than a ULR in another case. And really the only one that in that scenario understands the priority is the client that is sending the request. In fact, all of these cases, an agent in the middle of the network isn't likely to be able to derive the priority of that request from the content of the request based on what's there today. Okay, next slide. Okay, so I've got a few design questions to kind of, in a similar way that we just talked about with load, identify how we would design this mechanism, assuming that it gets taken on by the group. First is, how closely do we align this with what's already been done in RAI in the SIP area? There's an RFC 4412 that defines the concept of SIP resource priority. It's a similar question. They have a similar set of use cases that they're trying to address. It's basically, again, the ability to, on a call setup basis, the resource priority can be used for allocation of resources or routing decisions. A question?
Yeah. Since there is no associated bearer, preemption and priority queuing are not relevant. Exemption from throttling should be the primary treatment.
What was the last part of the exemption?
Exemption from throttling should be the primary priority treatment. This is from Jay Gunn.
Okay, and I agree that the base use case here is exemption from abatement or throttling. The feedback I've gotten in talking to others is that we should not constrain it to just that. If an agent wants to use priority for making some kind, agent or a server even wants to use it for making some other kind of resource allocation decisions, they shouldn't be prevented from it. But yes, the basic use case is to exempt requests or to minimize the probability, to be more accurate, requests from being throttled.
Yeah, Martin Dolly. So, I mean, one could actually use this for the coal emission as well. So, I mean, if you look at the real-time emit district coal point that was defined several years ago, the onus of that was for government priority services. And what it does, the per hop behavior is such that this packet recognized gets higher in the queue for emission. And so this type of indicator could also be used for that type of admission to get it out of the box quicker as well.
Yeah, and agreed. And keep in mind, we're just talking about diameter signaling here. How this is the interaction with other parts of the network and individual packets flowing through the network is completely orthogonal to this. This is just diameter signaling messages resulting from an initial attach or other scenarios.
Also, he agrees with Martin And he says, but you do not need to assign each namespace as one or the other.
Okay, so that's a namespace question, yeah, and that's assuming we have namespaces, which is really the core of this question. The SIP approach defined multiple priority namespaces, and basically that's multiple groups of priorities, where you could have a separate priority definition. There are two things that are defined when you define a namespace. One is the priority values that are possible in that namespace, and the other is the preemption behavior, or the behavior when you're differentiating traffic. And preemption and priority queuing are the two separate behaviors that a node of the network can take based on that priority. There's a fair amount of thought put into the SIP work. I wanted to bring it in here and see if we wanted to leverage it for what we're doing. We don't have to by any means. If we want to stay with a single set of priority definitions that are used in all cases, we can certainly do so. The SIP, as I understand it, I was not involved in the SIP work directly. I've read all the specs. As I understand it, part of the reason for multiple namespaces is that the SIP calls can traverse, the SIP signaling can traverse multiple administrative domains, and each administrative domain may have its own view on how to set priorities. And so you might have one domain setting a government-related priority, another domain setting a different government's-related priority. The weakness in the SIP approach is that the way it's specified is you have to configure the relationship between those namespaces and any node that is going to handle multiple namespaces. So it's they kind of punted the interoperability between namespace concept.
Okay, Martin Dolly. I think for diameter, I think it's simple to have it binary. So, normal and priority. I don't think we need to differentiate between namespaces or even user levels within a namespace. Primarily because this is only dealing with the signaling, where with SIP, those namespaces and priority values associated with the namespace also influence, the bearer setup and the priority of the bearer, where this is not necessarily the case here. This is just the signal.
Yeah, that's fair. And we don't have to answer this now, but this is one of the conversation points, of whether we have a single namespace in essence, or whether we have multiple. Next slide. So the next question is the method of encoding. And related to this question is the number of priority levels. I mean, Martin just said 2, low priority, high priority. I think you probably need more than 2. Most of the priority sets are 5 or 8. Some historical places where you can specify priority have up to 64 or maybe more, but I don't think that makes any sense. But related to that, then the question is, where do we carry that priority information? And there's really 2 options, 2 primary options. One is we can steal some of the reserved command flag bits. There are 4 bits available. If we stole 3 of them, then we could have 8 priority levels. If we stole 2 of them, we could have 4 priority levels. I don't know how our chairs feel about using command flags for this. The other option is to use AVPs, in which case, if you're using AVPs, then you really don't have any physical limitation, structural limitation on how many priority values that you want to have. The advantage of command flags is there's no parsing overhead. It's pretty simple to determine the priority. Disadvantage is there's a limited number of those bits available, and it's not really not extensible if you use command flags.
Lionel, as an individual, I think that there is another alternative also. It's that, so using an AVP, but if you are using AVP, I think it was a comment from Uni, and I had the same, is that if you need to parse the comment to be able to find this AVP, and based on this parsing you will know what to do in the queuing mechanism, it could be maybe painful to do that. Using the common flag for me would not be so appropriate for this specific purpose, except if you want to have this as a general mechanism that would apply to any of the commands.
That would be the assumption. If you're using command flags, then it's a generic mechanism, yeah.
And another point would be that if it is only about indicating a set of priority, I think it will rely anyway on kind of SLA between server and all the nodes sharing this information, because if you are saying that this message need to have the priority 1, you need to ensure that the other one will apply this priority as indicated by the server. So if you are negotiating some policies between the servers, the nodes, maybe you may define different policies and just provide in one message the type of policies that you would like to apply. So it could be just an index instead of having to send all the priority level for all the message. It could be just an index and change between the nodes.
But that policy would have to be on a per user basis.
Sorry?
You're saying you pre-send the priorities and not signal it in every message?
No.
Oh, I'm
I
not
think that
understanding.
you will need this information as soon as you will exchange. So, for instance, at the application level over A6A, you will need to say, as soon as there is an overload situation, you will have to perform this kind of prioritization in the network. And this information should be received as soon as possible, even before the overload situation. Because if during the overload situation, I think it would be not so useful to add extra process. I think that you need to set up this filter before.
So I don't understand what you're setting up before, though. What does that contain?
For instance, it could be outside the signaling or inside the signaling. It is something that could be defined. You are indicated the type of profile that you would like to use, the type of filters that you will use for this application, for instance, and so it could be done by provisioning and just send an index value that will inform the node which filter to apply for this application.
But that boils down to just sending a priority with each message. You're saying that. I'm not discounting what you're saying, but there may be value when you're saying that a client can send in advance, these are the priority levels indexes that I'm going to use, but it still has to signal in each message which one to use for that message.
No, for me, my assumption was that it could be valid for if the main purpose is to prioritize one message compared to another one. This information will be sent at the real beginning. So at the real beginning, yeah.
Wait, are you saying command code when you say message? Are you saying prioritizing command codes?
Yeah.
I'm saying for the same command code prioritizing messages. You're going to use the same command code as a early responder as I'm going to use as a normal user. Your messages need to have a higher priority than mine. So it's not on a message type basis, not on a command code basis, it's on a per transaction basis at least, that you need to be able to specify the priority.
But on which information you will be able to do this prioritization?
The sender of the request. The client is normally the client. The sender of the request has to understand how to set the priority. That's outside. That would not be specified as part of this specification. So there's going to be some policy that the client uses to specify the priority on an individual user basis. Database lookup, signaling coming from a non-diameter path, whatever it is, it's going to use that to specify the priority and then include that in the request.
Okay, so Martin Daly. So I agree with that. That was going to be my starting point, but yeah, when it comes to things like priority, it's baked into your trust model, and which is based on your policy, your local policy. I think though, I think we ought to. I still believe it should be either normal priority or high priority. I think if someone wants to justify more than that, I think we ought to have that discussion. And I think the indicator should be as outside of the envelope as possible. The deeper you put it in, i.e. in an AVP, would prefer to keep it out as far outside the wrapper so that it can be looked at very quickly.
Yeah, and so, if we went with what you just proposed, then one bit in the command flag would be enough. We just need to balance that with extensibility, and there may well be people who can come in here and say, in fact, if you look at WPS and other priority schemes, there are more than 2. That doesn't mean we have to inherit all of those, but the extensibility and the flexibility is something that plays into this as well.
Okay. As an individual, just a question. So I have some vague memory that this has been discussed before, that could we use transport layer mechanism to signal this also, like for example in case of SCTP using PPID or something like that?
We actually talked about this, and I don't know how deep we want to get into these conversations, but because it's not even a working group draft yet. But one of the issues with using transport layer priorities is it's not always possible to differentiate on a message by message basis what the priority is. TCP, you generally don't have the ability to have access to the priority marking of the message coming in. In TCP, it's generally on a per connection basis that you set the packet marking, not on a per message basis. SCTP, that might be possible. I've gotten conflicting reports on that, some saying that you can, some saying that you can't. You certainly could force a configuration of an SCTP stream or a TCP connection to be one priority or another and make the determination based on what connection it comes in on. But that seems troublesome to me, and the lack of layering in the definition seems troublesome to me as well. There may be reasons to set a separate transport layer priority from your application level priority, where if we're tying the two together, you're saying you can't have a different application level priority than transport. But you'd have to change the TCP, at a minimum you have to change the TCP socket interface in order to do this on transport level. And I'm pretty sure people I've talked to would not accept saying, well, if you want to do priority, you have to do SCTP. There are enough applications that assume TCP out there today that probably wouldn't fly.
Buying television networks. One question. Wouldn't it make sense to use a combined solution? So have one bit in the command flex bit to indicate that we have priority, and to also define ADPs based on the SIP emergency or SIP RFC or whatever. Because there are certain cases where I have to also differentiate between I have an emergency call or I have a priority call for a certain user.
Right.
And in overall scenarios when I can go around this abatement solution, I have to decide which one to drop, for example. So this may be one solution.
That would be one possibility as well. It would give the advantage to an agent or an endpoint that it doesn't have to look for the AVP if that bit wasn't set, basically. Okay, let's go on. Obviously, we have a lot of discussion on this that will have to happen, but I want to get through the basic questions and see if the group agrees to take this on before we dive too deep. So the next slide is whether this is a base protocol extension or an application extension. If we went with command flags, then it's by definition base protocol definition. If we don't, then it would have to then what we define here would be like what we did with DOIC, where applications would reference this and to include support in that application. I do think it's important, this last bullet, that if we do this on a per application basis, that the basic behavior not be different between the applications. If we're trying to optimize the handling in a overload or some other kind of constrained environment, you don't want to have agents have to understand application level semantics for every request that it handles. So I think this this information logically actually falls into a routing level AVP. If we do AVPs, and it becomes a base protocol level extension. But that's a rat hole that we can avoid for now and talk about if we go forward. Next slide. Scope of the priority setting. Does the priority setting specify the priority for a single message? So within a transaction, you can have the transaction is priority 1, or the request is priority 1 and the answer is priority 2, or whatever values you specify for it. Does it apply to the transaction, so that if the request is priority 1, the answer is by definition priority 2, or just the request messages and answers have an implied higher priority because you've already invested the resources to handle the requests, so the answer should flow through the network at a higher priority than requests. I've seen arguments for all three. I believe that the way that WPS, one of them, implies that it should be number 2, that if it's dealing with an emergency responder, then the request and the answer should have higher priority than everybody else. I've seen other definitions where the answer messages have a higher priority by default because they are more important. You don't want to have retry storms happening if you're arbitrarily dropping answer messages. So.
Okay, so this is Martin Daliak. So I think that from a mechanism perspective, you're going to mark priority on every message, okay? I think to the point in bullet 2, to me that's an application. I mean, if you're a server, you're going to, process messages that are within an established, dialogue or transaction before processing new ones. In general. So I think that's maybe.
Okay, so on the first point, if we went with number 2, then you do not have to explicitly mark the priority in the answer message because every node of the network has state associated with that transaction that it can save as a part of when it handles the request, it can save the state about the priority and apply that to the answer. And that decreases the overhead of answer processing. You don't have to parse to get that.
If you mark it, okay, so let's say you have a diameter agent that is a pure proxy, doesn't maintain any state whatsoever. By marking it on every message, then it would know what to do with respect to doing any type of.
But there is no such thing as that entity you just described. By definition, in diameter-based protocol, an agent must maintain transaction state, and that's how it knows where to send the answer message. The answer message itself does not carry routing information. The state that you save hop by hop tells that agent where to send that answer next hop. It's not carried in the message itself like it is in SIP.
Okay, so within sort of like the stack, right? Mm-hmm. If you have it up front in a command bit, then upon a node, a box receiving it, it knows this message is priority before it even parses the message to know what transaction it's with. So having it on a per message basis gives you the more desirable.
Yeah, I think that the point, if you're using command bits, it's going to be on a per message basis. If you're not using command bits, it doesn't have to be on a per message basis. And if you're using AVPs and you go with option number 2, then there's actually an advantage to not put the AVPs in the answer message because you don't have to parse for the priority. You can use the fact that you already have state associated with that transaction to process it. Okay, next slide. Okay, so next steps. My request is that we add this as a working group item and accept this draft as a starting point for that work.
Thank you. So, further question on this document? No? Um, I would say that we just initiate the discussion on these drafts. We haven't received for the time being, at least on the mailing list, any comment on this one, so maybe it's too soon for that. Is there an interest to go forward, so for people in the room to go forward on this document? So please, just for information. So what I would, you mean, what I would propose is to go on, so to start the discussion on the mailing list, or even so to discuss with Steve and to provide comments, trying to clarify what would be needed in the document. And as soon as we will have a new version of the document with something stable enough, we can consider to as a working group document, as we have done for the load conservation
Sure,
document.
so Prague will, I'll ask the same question, and hopefully we'll have enough
Yes.
advancement of this to, yeah.
So for this document and for all the documents, I would really encourage people to provide as soon as any comment on the document and try to trigger a discussion on the mailing list. It's not to have some activity on the mailing list, but it's for the chair point of view, it's a way to see if there is interest, a real interest, and outside of the meeting. Because in the meeting there is a lot of interest, but between the meetings, time to time, it's quite difficult to motivate people. But Martin will ensure that everyone will contribute. Okay, thank you, Steve. And thanks a lot for the time and the presentation. So, it is nearly the end of the session. We're on track, and okay, so it's not the good one. Neither agenda. Okay. So the only thing that to discuss is, so first of all, Kathleen is the new AD. So maybe, yeah. So on behalf of Benoit, that has other responsibility regarding young model and so on. So Kathleen will be our ID. So normally she's from the security area. And now we have some good guys on the security, at least. So please, Kathleen.
So thank you. And so Stephen was covering for me this morning because we had a conflict with the Miles session. So I apologize for not being able to be here. And he was letting me know about the encryption discussion. We had chatted about that as well in advance of the meeting. And I'm not sure if, Stephen, did you already?
No,
Okay,
not yet. It was
great.
part of my, so it was right now that we have to discuss this point
Okay, great.
for the next step.
Yeah, so I just have a couple of quick suggestions to see if we could throw life into it now that me as the AD, maybe, you know, if we have you come and give a report for SAG, for working groups that are related to security, and if you could stand up at the mic and request assistance with this particular problem when we call out DIME. And then another idea, we can ask the security working group chairs directly, and I can introduce you to some of them, I think both of you tomorrow.
Okay.
So maybe we'll get some movement there.
Okay. Yeah, just to try to sum up the discussions that we had since the beginning of the week, there is a lot of activities around end-to-end based mechanism, and we have a specific requirement for end-to-end security over diameter, but we will not have any specific end-to-end mechanism to use as soon as this document will be approved as RFC for DIME. So we will need to have a mechanism for diameter, and the question was raised to say, I think that we are not able to define any security end-to-end security mechanism in DIME. So we need to rely on something that will be developed by someone else. There is ongoing discussion about new mechanism, and as soon as we will be able to provide our specific requirements regarding end-to-end security, the more we will be able to have something adequate to our specific requirements.
Kathleen again. So that Lionel was letting me know that there was some interest in Jose. There may be a new effort coming out called COSY, and so a mailing list is going to be requested on that to help form a charter and see if that should be a separate effort. And since you have things like GMSA that you have to consider, small might improve things, it could be good to get a few folks from this working group on that list to influence requirements if that's something that you're going to use. And they have a tight timeline. ACE also has a requirement for something similar, and they need everything yesterday. So I don't think it would take forever, but feeding in your requirements would help.
Yeah. Actually, it was a question for Uni, because Uni was one of the authors of the document proposing to rely on a Jose for end-to-end mechanism. So do you think that it is something that is still valid, or you will promote that, or you don't know?
Yeah, that was a proposal a few years ago. So I'm not sticking into that. So let's see after we get the requirements done. So we just happen to use JSON for encoding our security stuff.
And so we have received late comment on the security requirement documents, but it's close to be in a working group last call, and the next step will be anyway IESG evaluation. So I think that for you, Kathleen, and Stephen too, I think that you will see the type of requirements. So, this document is capturing requirement also from GSMA or whatever. So the set of requirements put in the document will also indicate the type of end-to-end security that we need at the diameter level. So we could rely on that. So a couple of documents have been adopted as working group documents. So we will update the charter, and we will also update the milestones. So we will propose some milestones for the working group documents with a special handling of the one on the load consideration, but we will see how to do with this one. And we will, after the meeting, so there is, so we will confirm the working group document adoption, and also ask for review regarding the working group document, and also the new document proposed by Steve. And I think that's all for me. Anything else, Uni? Anything else, Kathleen, Stephen? Okay, so thanks a lot. Thanks to be in the room. It was a nice meeting. See you at the next IETF meeting, and see you on the mailing list. And do not forget that we can set up conf call at any time. So it's something that we are doing for overload and load, but it could be done if required for any other topic. So thank you, and have a nice day. Why not? Bye-bye.
Thank you.
Have a nice whatever.
Beer?
Sorry? I have the boogie, so thank you.